Welcome back, algebra class, to another Mr. Chow time. This time we're solving equations that have absolute value. And so I guess first we should talk about absolute value. Absolute value is that thing that looks like this, or this, or this. These are all the same thing, right? These symbols here, these vertical lines are the absolute value symbol, and the absolute value just is an operation for determining the distance that value is from 0. And remember, distance is always a positive number. You know, for example, if you're over here walking, right, or that's a person walking or dancing, and they're facing this way and they're like running along, yay. If they travel in this direction 1 meter, or if they run backwards 1 meter, they're traveling 1 meter either way, right? It's not like if you start walking backwards, suddenly you're traveling a negative distance. The distance measurement is always positive, and so an absolute value is positive. That's not to say that there aren't negative values when we're talking in relative terms. You know, like when we're talking about like below sea level, we do use negative numbers, but that's not a negative distance. That's just a negative in relation to a mark that we've set. Okay. For example, the absolute value of c equals 7. So when you evaluate this, there's two possible answers, right? You can have c equals 7 or c equals negative 7. And both of those values would be true. And so that's what we're dealing with today. So let's take a look at this. Essentially, what we're saying is that whatever a plus 2 is, this is going to be a positive number, right? So a plus 2 is going to equal 6, the absolute value of a plus 2. But a plus 2 could equal 6, and that could be true, or a plus 2 can equal negative 6, and that would still be true, because if a plus 2 equals negative 6, you take the absolute value of negative 6 and you get 6, right? So we have to solve for both cases. So if we subtract 2 from both sides here, a equals 4. And if we subtract negative 2, or subtract 2 from both sides here, we get negative 8. And so in both cases where a equals 4 or a equals negative 8, our equation would be true. So why don't you go ahead and try this one on your own, and we'll come back and do it together. Welcome back. Okay, so here we have 3n plus 2 equals negative 5. So is that ever going to be true? No. We're not going to ever take an absolute value of this number and get a negative 5. So here we have no solution. The old no solution has come back to help us out. Okay, let's take a look at a real-world example. The temperature of my classroom should be 23 degrees, give or take 2 degrees. So we're going to find the maximum and the minimum temperature. So one way to think about this is if we were looking at a number line, and here's 23 degrees. This is the temperature that I like my room to be at. It could be 21 degrees or it could be 25 degrees, right? And that would be the comfortable range of my room. So how can we write that? Well, we can see here that if we take 25 and we subtract 23, then we get our 2 degrees difference, right? And if we take 21 and we minus 23, then we get our negative 2 degrees difference. And this is the plus or take, right? Plus or minus. So if we take the absolute value of this, then we would just get the positive, right? So to write our equation, we take our middle point and we place that in the absolute value. And we subtract that because it's the thing that, the difference that we're trying to find from the range, from the both sides of the range. So both sides of the range, in this example, we don't know what those temperatures would be, right? So that would be an x. And then our difference is going to be 2 degrees. Give or take 2 degrees. And so this is how you write an example, an equation for the situation. And then we would just solve this. X minus 23 equals 2. X minus 23 equals negative 2. And then we just add 23 to both sides on both equations. And yeah, we get it. Do we have space? Yeah, I do. X equals 25 and x equals 21 over here. Okay. So why don't you go ahead and try that on your own. An ice cream should be stored at 5 degrees Fahrenheit with an allowance of 5 degrees Fahrenheit. So you're going to write and solve an equation to find the maximum and the minimum temperature in which the ice cream should be stored. Welcome back. All right, so x, this is going to be the maximum, minimum temperature, right? And we are going to be trying, our middle point is 5 degrees Fahrenheit. And our allowance, the range, is 5 degrees on either side. So there it is. If we solve for this, x minus 5 equals 5, x minus 5 equals negative 5. Add 5 to both sides. X equals 10 here. Add 5 to both sides. X equals 0. So that's the range of values that we can have for ice cream. So that's for that. Yep. So that's it for me this time. Have a good one. Bye.